Imagine this. You are standing on Earth, holding half of a mysterious coin. Your friend flies to the other side of the galaxy with the other half. The moment you flip your coin and it lands heads, their coin instantly becomes tails. Not a second later, not after a signal travels, instantly, no matter if they are 1 mile away or 1 billion light years away. This is not science fiction. This is quantum entanglement, and according to experiments performed for decades by physicists around the world, particles can share information faster than light itself. Which raises a terrifying question for physics. Did Albert Einstein get something wrong? Or is reality stranger than we imagined? Today, we are diving down one of the deepest rabbit holes in science. And trust me, by the end of this video, you may start questioning what distance, reality, and even existence actually mean. The strange birth of quantum mechanics. Our story begins in the early 1900s. Physics was feeling pretty confident. Scientists believed they had nearly solved the universe. Gravity? Understood. Motion? Solved. Light? Mostly explained. Physicists were basically saying, give us a few more years and we'll finish the universe. Then, quantum mechanics arrived and politely threw the entire rulebook into a volcano. Experiments started revealing something bizarre. At extremely tiny scales, atoms and particles, nature behaved like it had lost its mind. Particles behaved like waves. Waves behaved like particles. Objects could exist in multiple states at once, and observation itself seemed to change reality. Physicists began realizing the universe at its smallest level does not behave like a machine. It behaves like a probability cloud with attitude. Enter Einstein, the skeptic. Now enter one of the greatest minds in history, Einstein. Yes, the same man who gave us relativity and the famous equation E equals mc squared. Einstein helped create quantum theory, but when things got weird, he drew the line. One prediction of quantum mechanics especially annoyed him: entanglement. The theory suggested that when two particles interact, they can become linked. Their properties become shared. Not connected by wires, not communicating by signals, but existing as one combined system. If you change one, the other responds instantly. Einstein hated this idea. He called it spooky action at a distance, which is probably the most polite way a genius can say, this theory is insane. Einstein believed hidden variables must exist, unknown factors secretly controlling outcomes. Quantum mechanics, he believed, had to be incomplete. So he challenged the theory, and for decades, physicists tried to prove him right. The experiment that shocked physics. In 1964, physicist John Bell proposed a way to test Einstein's objection. It became known as Bell's theorem. Bell realized something brilliant. If hidden variables existed, certain statistical patterns would appear in measurements. But if quantum entanglement was real, those patterns would be impossible. So scientists ran experiments, then more experiments, then thousands of experiments. Particles were entangled, separated, and measured. The results were shocking. Over and over again, the universe sided with quantum mechanics, not Einstein. Two entangled particles behave like one system even when separated across vast distances. When one particle is measured, the other instantly adjusts. No delay, no signal, no waiting for light to travel. It simply happens. Wait, does this break the speed of light? Now hold on. Before we panic and rewrite physics textbooks, we need to clarify something. Entanglement does not technically send usable information faster than light. You cannot send a message this way. You cannot use it to text someone across the galaxy, unfortunately. Otherwise, long-distance phone plans would finally be free. What entanglement does instead is create perfect correlations between particles. When you measure one particle, the outcome of the other is instantly determined. But until you compare results later, you cannot control what outcome appears. So relativity survives. Barely. But the deeper mystery remains. How do two particles remain connected across space? The universe might not be local. Entanglement suggests something deeply unsettling. Reality might not be local. In everyday life, things only influence nearby things. You push a chair, the chair moves. Simple. But entangled particles ignore this rule. They behave like two ends of the same object, even when separated by vast distances, which leads physicists to a disturbing possibility. Space itself might not be as fundamental as we think. Some scientists believe entanglement suggests that reality is built on a deeper layer beneath space and time, where distance simply doesn't exist. The universe might be woven from entanglement. In modern physics, some of the most exciting ideas suggest something wild. Space-time itself might emerge from entanglement. In certain theories combining quantum mechanics and gravity, physicists discovered something shocking. The geometry of space itself might actually be constructed from networks of entangled particles. Imagine reality like a massive cosmic fabric. Each thread is an entangled relationship, not objects connected through space, but space emerging from connections between objects. In other words, entanglement might not be a weird feature of the universe, it might be the foundation of the universe. And this isn't just philosophical, we are already using it. Quantum computers rely on entangled qubits to perform calculations impossible for classical computers. Quantum cryptography uses entanglement to create unbreakable encryption, and scientists have even entangled particles across satellites orbiting Earth. China's Messias satellite demonstrated entanglement over 1,200 kilometers, which means the spooky phenomenon Einstein disliked is now powering the next generation of technology. Einstein would probably roll his eyes, but also secretly be impressed. The deeper question. But here is the real rabbit hole. Entanglement suggests the universe might not be made of separate things. Instead, everything might be part of one giant interconnected system. At the deepest level of reality, separation might be an illusion. Particles, fields, space, time, all emerging from deeper relationships we barely understand. Physics started by asking, what is matter made of? Now it asks something even stranger. What is reality made of? And entanglement might be the first clue. The closing thought. Einstein once said, the most incomprehensible thing about the universe is that it is comprehensible. But quantum entanglement reminds us, maybe the universe is only partially comprehensible. Maybe reality is deeper, stranger, and more interconnected than our brains evolved to understand. Two particles, separated by galaxies, still acting like one. No wires, no signals, just the quiet whisper of a universe telling us everything may be connected. If this blew your mind, type entangled in the comments, because in the next video, we're diving even deeper into the rabbit hole. Could the entire universe be a quantum computer? And if it is, what or who is running the program? I'll see you in the next one.